Hello and welcome to today's lesson. Today's lesson, we will be taking fractions and turning them into decimals. So your learning target for today is I will be able to write a rational number as a decimal. So what is a rational number? A rational number is any number that can be written as a ratio in the form of A over B. So A over B, where A and B are integers and B is not a zero. We cannot have B be a zero because you cannot divide by zero, so that's why B cannot be zero. So some examples of some rational numbers are this number 6, because can we write 6 as a ratio of 6 over something? So what can we write it as? Well, we can write it as 6 over 1, and then it's in the form of A over B. So 0.5 is a decimal. Can we write that decimal as a ratio? Most of you know that 0.5 represents the fraction 1/2. So we would have 1 over 2. Okay, and the last one that we have here is 0.3 with that bar above it, and most of you guys know what that bar above it means is that something is repeating. So what fraction did this come from? Well, if we write it as 1 over 3, that is what it came from. Which leads me to the last two terms on this page, a terminating decimal. A terminating decimal has a finite number of digits. So this example right here, this is a terminating decimal. It ends. It's 0.5. There's a finite, certain set of digits. It's 0.5. That's it. Nothing's repeating, nothing going on after it. Repeating decimal has a block of one or more digits that repeats indefinitely. So in this second one that we did, 0.3, with that repeating above it, it is 0.3333333. We always know what number comes next. So that would be considered a repeating decimal. So we're going to look at some rational numbers here, which means numbers, we're going to be looking at fractions, and we're going to convert them into decimals. So write each fraction as a decimal. So this fraction 1/8 is a rational number. It's a ratio of 1 to 8, and we can write this as a decimal. So we get to do some of your favorite stuff and do some long division. Remember, the denominator goes on the outside, and the numerator goes on the inside. Now, we ask ourselves, does 8 go into 1? And 8 does not go into 1, so we can put a 0 at the top. Remember, decimals are always at the end, so we have 1 point. So I'm just going to put my decimal up here. 0 does not go into 1. So remember, we can add a 0 here after that decimal, and now we're asking ourselves, does 8 go evenly into 10? And it does. It goes in there one time. So we make sure we put it above the 0, and now 1 times 8 is 8. And now we're going to take 10 minus 8, and 10 minus 8 is 2. Now that's a remainder of 2, and we're not looking for any remainders or fractions. We're trying to get this to a decimal, either repeating or terminating. So does 8 go into 2? No. So we put another 0 at the top, and we bring that 0 down, and now we're talking about 20. Does 8 go into 20? And it does. So how many times does 8 go into 20 evenly? And then there's going to be a little bit of remainder. That's fine. So we have 2. 8 times 2 is 16. And now we're going to do 20 minus 16 is 4. And again, there's still a remainder, so we have to keep going. This did not terminate, and it's not repeating in any way. So I'm going to add another 0 and put a 0 here. Now does 8 go into 40? And the answer to that is yes, it does. It actually goes in there evenly. So when we take 5 times 8, we get 40, and when we subtract, we get a 0, so there's no remainder. So 1/8 is the decimal. This decimal ended. We don't keep going. There's no remainder. Nothing's repeating. So this is a terminating decimal of 0.125. So 1/8 and 0.0125 are equivalent. One in fraction form, one in decimal form, and they are both considered rational numbers. All right, second sample here. So we have a rational number, it's a ratio. And remember, we put the denominator on the outside and we put the numerator on the inside. And 11 does not go into 5, so we put in a 0. And then we have to put in our decimal so that we hold that place value. And I put in a 0. Does 11 go into 50? And it does. So if I think about 5 times 11 is 55. That's a little too big, so I'm going to go one smaller. And I'm going to pick a 4. 4 times 11 is 44. And now we're going to subtract 50 minus 44. 50 minus 44 is 6, and that's a remainder. So it did not end, it did not terminate. So I'm going to add another 0 and pull this 0 down. Does 11 go into 60? It does. So let's see, in that last one, we just said 11 times 5 was 55. So 5 times 11 is 55, and we're going to subtract those. So 60 minus 55 is 5. Again, we have a remainder, so I'm going to put down my 0 and I'm going to bring it down. 11 goes into 50. Wait a minute, that's what I started with, was 50. So it looks like that's going to be the same answer of a 4. And what's going to keep happening is this is going to repeat. We're going to keep going from 50 to 60 to 50 to 60. So that means what is repeating here? Well, right here, this next one would be a 5, so you can see 4, 5, 4, 5. So this one is a repeating decimal of 4, 5. We don't want to write more than we need to, so we're just going to write 4, 5. And then the 4 and 5 is repeating, so we put the repeating bar above the 45. All right, and then last one here. So we have a whole number in front of a 3. And then we have a fraction of 4/9. So when we're done, and this is going to be a decimal, it's going to be 3 point something. So what I really need to find is the decimal part of this. So all I'm going to do is look at this fraction part, and that's what I'm going to put into my long division. Okay, I'm not going to forget about the 3. I need to use the 3 at the end, because my answer is going to be 3 point something, whereas in these last ones, we had a 0 here at the top. Okay, so this one's going to have a 3. So you can do this. We're going to have a 9 on the outside, because remember the bottom always goes inside, and then we have a 4. So 9 doesn't go into 4. So we have a 0, so now we have a 0. 9 goes into 40. How many times does 9 go into 40? Well, 9 times 4 is 36. So I put a 4. 9 times 4 is 36. And now 40 minus 36 is 4. Well, that's what I started off with, is a 4. So when I add a 0 down here, 9's going into 40, just what I started with. So it looks like this is going to be a repeating decimal. So the 4/9, doing long division, we get a repeating decimal of 0.4 repeating. But remember, this whole number was 3 4/9, so I need to make sure I put that 3 in front, and so this 3.4 repeating is that fraction as a decimal. All right, please review as you need to, stop and go forward, and good luck on tonight's homework.